All right, how's everybody doing out there in calculus land? This is Mr. Muscarella, hanging out with my good buddy here, L'Hopital, and we're going to take a look at these indeterminate forms and when we can apply L'Hopital's rule. Now, indeterminate forms, just so you remember, are going to be when we have a limit that takes the form of either 0 divided by 0 or infinity divided by infinity. Now, there are several other indeterminate forms. 0 times infinity, or infinity minus infinity, 1 to the infinity, 0 to the infinity, and of course, infinity to the 0 power. Anytime you end up with one of these other indeterminate forms, we've got to do some math trickery, some algebra, using properties of natural logs to get that other indeterminate form to be either 0 over 0 or infinity over infinity. So, enough about that. Let's go ahead and take a look at our first example. So here we are. We've got to find the limit as x approaches negative 1 of x squared minus x minus 2 divided by the quantity x plus 1. Now, of course, you always want to use direct substitution first. So when we do that, when we put negative 1 in everywhere for the x, we get negative 1 squared minus negative 1 minus 2, all of that over negative 1 plus 1. So the denominator is going to be 0. Negative 1 squared is 1 minus negative 1. So that gives a sum of 2 minus 2. So we end up with 0 over 0, which is one of the indeterminate forms for L'Hopital. So we can apply L'Hopital's rule here. And when we apply L'Hopital's rule, what we're simply going to do is take the derivative of the numerator and the denominator. The derivative of x squared minus x minus 2 is going to be 2x minus 1. The derivative of the denominator is just 1. Now, when we apply direct substitution again, we plug in negative 1, we end up with 2 times negative 1 minus 1, which gives us a value of negative 3. Now, an alternate technique for this particular example could be when you use factoring. A lot of times when people see rational functions, they're like, hey, let me see if things will cancel when I do my factoring. So in this particular case, when you factor x squared minus x minus 2, that factors into x minus 2 times quantity x plus 1, and all of that is over x plus 1. Now, of course, these factors will cancel out, which means you're left with the limit as x approaches negative 1 of just x minus 2. Now, one common error, so make sure that you do this. A lot of students do this. Make sure that you write the lim part, limit as x approaches negative 1. If you drop that when you're evaluating limit stuff on the AP exam, you will lose a point. All right, so make sure you keep that in there. Now, of course, now we can use direct substitution, and you plug in negative 1 minus 2, you end up with a value of negative 3 again. So you could have either solved this problem using L'Hopital's rule, or you could have solved it using direct substitution after you cancel out like factors. Alright, that's it for this video. Thank you guys for watching, and I'll see you again soon. Have a great day. Peace out.